Hey there, science fans. Welcome to another exciting episode where we dive deep into the wonders of the world around us. Have you ever noticed how much things change around us? From the moment we wake up to the time we go to bed, change is happening everywhere. The weather changes every day, sometimes even within the same day. Plants grow taller and flowers bloom, adding beauty to our surroundings. Cars speed up and slow down as they navigate through the busy streets. The hustle and bustle of city life is a constant reminder of change. Change is a fundamental part of our universe. From the rotation of the Earth to the shifting of the seasons, everything is in a state of flux. And guess what? Math can help us understand and measure these changes. It's like a language that decodes the mysteries of the universe. That's where differentiation comes in. It's a powerful mathematical tool that helps us analyze how things change. Differentiation is like a special tool in our mathematical toolbox. It allows us to break down complex changes into understandable parts. It allows us to look at how things change over time, whether it's the growth of a plant or the speed of a car. It's like a superpower that helps us unlock the secrets of motion, growth, and transformation. Imagine being able to predict how fast something will grow or how quickly it will move. So, buckle up, because we're about to embark on an exciting journey to demystify differentiation. Get ready to explore the fascinating world of change through the lens of mathematics. In the simplest terms, differentiation is all about finding the rate of change. Imagine you're driving a car, your speed is constantly changing, right? Differentiation helps us calculate exactly how fast your speed is changing at any given moment. This rate of change is called a derivative. Think of it like this. The derivative tells us the instantaneous speed of change. It's like taking a snapshot of how fast something is changing at a precise moment in time. Pretty cool, huh? Let's bring differentiation to life with some real-world examples. Imagine you're on a roller coaster. As the coaster climbs the hill, its speed changes. Differentiation helps engineers calculate the coaster's speed and acceleration at every point on the track, ensuring a safe and thrilling ride. Or consider the stock market. Stock prices fluctuate constantly. Financial analysts use differentiation to analyze these changes, identify trends, and make informed investment decisions. Differentiation is like a secret weapon for understanding the ups and downs of the financial world. Now let's dive a little deeper into the concept of derivatives. Remember, the derivative represents the instantaneous rate of change. It tells us how much a function's output changes with respect to a tiny change in its input. We can visualize the derivative as the slope of a tangent line to a curve at a specific point. The steeper the slope, the faster the rate of change. The derivative gives us a precise measure of this steepness. Section 5. Differentiation, a universal tool. Here's the amazing thing about differentiation. It's not just limited to math class. It has applications in countless fields, from physics and engineering to economics and biology. Physicists use differentiation to study motion, velocity, and acceleration. Economists use it to analyze market trends and optimize production. Biologists use it to model population growth and understand biological processes. Differentiation is truly a universal tool for understanding our world. Section 6. Taming the differentiation beast. Basic techniques. Don't worry. Learning how to perform differentiation isn't as scary as it sounds. With a bit of practice and understanding, you'll find it to be a powerful tool in your mathematical toolkit. There are some basic techniques that can help us tame this mathematical beast. These techniques form the foundation of calculus and are essential for solving more complex problems. One fundamental rule is the power rule. This rule is particularly useful when dealing with polynomial functions. It states that the derivative of x raised to the power of n is equal to n times x raised to the power of n minus 1. This means that if you have a function like x to the fourth power, its derivative would be 4 times x to the third power. For example, the derivative of x squared is 2x. This simple rule can be applied to any power of x, making it incredibly versatile. Another important rule is the sum rule, which tells us that the derivative of a sum is equal to the sum of the derivatives. This means that if you have a function that is the sum of 2 or more terms, you can find the derivative of each term separately and then add them together. For instance, if you have a function like x squared plus 3x, you can find the derivative of x squared, which is 2x, and the derivative of 3x, which is 3, and then add them together to get 2x plus 3. By mastering these basic techniques, you'll be well on your way to understanding more advanced concepts in calculus. Practice these rules regularly, and soon you'll find that differentiation becomes second nature. Remember, the key to taming the differentiation beast is practice and persistence. Keep at it, and you'll conquer this mathematical challenge in no time. Section 7. Differentiation pitfalls, common mistakes and how to avoid them. Differentiation is a fundamental concept in calculus, but it can be tricky. Let's explore some common mistakes and how to avoid them. Even the best mathematicians make mistakes sometimes. It's important to recognize these errors so we can learn from them and improve our skills. One common mistake is forgetting to apply the chain rule when dealing with composite functions. This rule is crucial for correctly differentiating functions that are nested within each other. The chain rule helps us differentiate functions within functions. For example, if you have a function inside another function, you need to apply the chain rule to get the correct derivative. Another pitfall is confusing the product rule and the quotient rule. These rules are essential for differentiating products and quotients of functions, respectively. The product rule tells us how to differentiate the product of two functions. It's used when you have two functions multiplied together, while the quotient rule deals with the quotient of two functions. This rule is applied when one function is divided by another. Remembering these rules and practicing regularly can help us avoid these common errors. Consistent practice and review are key to mastering differentiation and minimizing mistakes. Working with peers and seeking help from teachers can also be beneficial. Discussing problems and solutions with others can provide new insights and reinforce your understanding. Additionally, utilizing online resources and educational videos can offer further explanations and examples to solidify your grasp of differentiation rules. By being aware of these common pitfalls and actively working to avoid them, you can become more proficient in differentiation and build a strong foundation in calculus. Section 8. Keep it simple. Analogies and visual aids. Sometimes the best way to understand complex concepts is to use simple analogies and visual aids. Think of differentiation as finding the speed of a car. The derivative is like the speedometer reading at a particular moment. Graphs can also be incredibly helpful. By plotting a function on a graph, we can visualize its rate of change. The steeper the curve, the faster the rate of change, and vice versa. Section 9. Keep exploring. The journey of differentiation continues. Congratulations, science explorers. You've taken a crash course in differentiation and learned how to unlock the secrets of change. Remember, differentiation is a powerful tool with applications in countless fields. The journey of differentiation doesn't end here. There's always more to learn and explore. So, keep asking questions, keep practicing, and keep marveling at the wonders of mathematics.